This week we'll wrap up our XArray tutorial by creating a more complex XArray that has elements of time, height, pressure height, and some variables, and we'll learn how to slice and dice it. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I wanted to wrap up our several-part series on XArray here by creating a little more complicated XArray, and then we'll look at the select and iSelect function a little bit more closely than we have in the past. So of course we're going to import NumPy, import XArray, and I'm also going to import Pandas, just for its date range functionality, which we've gone over before and is just very, very useful. Okay, so what I want to create here is something that is a fake model output, let's say. So we're going to have a couple of variables. They might have different height coordinates, and there's going to be latitude and longitudes associated with them. So last week we had two-dimensional latitude and longitude grids because they were really just X and Y. But this week I'm going to go with something a little bit simpler. We're going to roughly cover CONUS. We're going to go from 20 to 50 in steps of 0.5 latitude. And longitude, we're going to go from minus 125 to minus 65 in half-degree steps as well. Now, one thing that's going to be very important is to keep track of the shape of everything. And we're going to print that out at each step of the way here as we create these arrays. So we've got 61 latitudes and 119 longitudes. Now I'm going to create some levels that one of my variables is going to be on. And these are going to be pressure levels. Notice I'm not using units. I don't want to add that complication yet. So we'll use 1,000, 850, 500, and 250 millibars. And we're going to print the shape of that. All right, now what about time? Here's where I like the Pandas date range function. And you've heard me go on about this before, how that its syntax is very simple and very powerful. So these are just strings, they're not even date-time objects. And I'm going to want a 24-hour forecast. And I want it hourly. So then we'll verify that that worked as we thought. Perfect, we have 24 time steps. All right, now we need to make our actual data. Last week we had some very small, simple arrays, so I was just inputting data by hand. This week we're going to use random numbers though. So from NumPy's random.random, we're going to specify a shape. Now I'm going to put time, and then the height levels, then the latitude, and then the longitude as my convention. So my shape is going to be what? Here's why we printed out all those shapes above. 24, 4, 61, and 119. Just to make sure that it did what we thought, you should always verify. 24, 4, 61, and 119. Okay, what about another variable? I'm going to make one that uses heights above ground level. Zero, 500, 1,000, 1,500, and 2,000. Let's just call that meters AGL. All right, so there are 5. Notice it's got a different shape. We had 4 pressure levels and we have 5 AGL levels. Now let's create a wind speed variable. So its shape is going to be 24, 5, 61, and 119. If we were using just plain old arrays or even a flat table, you can see how this would already be a complete nightmare. Okay, and the shape of wind speed. There we go. So now we're ready to actually make these variables data arrays. So I'm going to create my temperature data array, XArray.dataArray, and I encourage you to pause the video and try this yourself, because we went over how to do this last week, and there's really not a lot that's going to be different at this point. All right, did you get it? So the first thing is going to be our data, which is the temperature array. Then I'm going to specify its coordinates, which are times, levels, latitude, longitude. And I'm going to give it some dimensions, time, level, latitude, longitude. While we're at it, we're going to add more metadata because we are good data stewards. So we're going to set the name, and then under adders, I'm going to set a units attribute. This is about as close as we're going to get to using united quantities for now. And now we're ready to do the same thing for wind speed. So the wind speed data array, XArray data array, wind speed. Now our coordinates are going to be a little bit different. We still have times, heights instead of levels, latitude, longitude. I'm going to specify dimensions, time, heights, latitude, longitude. And I'm actually going to make heights singular here to follow our convention that we've been using. All right, so we're going to set the name to be wind speed. And we're going to set the attribute units. We'll be a little controversial here and use knots. All right, so now we've created these data arrays, and you can look at them if you want, just to verify that they're what we believe they should be. So there's our data, there's our coordinates, and there's our attribute. Okay, so now we're ready to make this into a data set. Remember, a data set contains multiple data arrays, multiple variables. All right, so our data set, XArray.dataset. The first thing that we're going to pass is a dictionary. Again, remember, there are a few ways you could do this. This is just my preferred syntax. Air temperature. Inside that, we're going to have a tuple with our dimensions. And our data array, temperature DA. All right, so now we need to add something else to our dictionary, which is what? It's our other data array. Wind speed. And we're going to follow the same pattern. A tuple, the first thing is a list. Of our dims, and then our data array. We close out that dictionary. Now we're ready to specify the coordinates. So for this, we're going to use a dictionary. We're going to associate the name with the actual array, the actual data. So time is times, level is levels, height is heights, line wrap, so it's a little bit neater here, latitude is going to be latitude, and longitude, longitude. Finally, again, since we are being good data stewards, I'm going to give this data set a title and call it my custom forecast, or my custom model. How about that? All right, so now we've created this data set, and we can look at it. We can see we both have the time and level dimensions and coordinates, latitude, longitude, and time. There are data variables. So this is all well and good, but how does this give us the benefit over just having several multi-dimensional NumPy arrays floating around, or lots of flat tables? Well, other than storing everything in one object that mirrors a netcdf-like format, which is already very nice, we can do some pretty neat selection operations. So I'm going to find an array that is the temperature forecast at a single time. So I'm going to index into my data set with the data variable name, then call .cell for select, and now I'm going to pass one of my coordinates. Time, I'm going to just use the string because these time objects work very nicely. I want the 1300 forecast. And in fact, I just want it at a given level. I just want it at 500 HPA. So what do you think we're going to get back out of this? What's the data type going to be? If you guessed data array, you are correct. It is an air temperature data array that just has the coordinates latitude and longitude because we have reduced the degrees of freedom of the system by specifying time and level. They're still there, so we can see that we're at the 500 level and at 1300 time, but they're not something we can index or slice into because, well, we've constrained them. But we can do even a little bit more. Well, first, I'm just going to verify what should the shape of this be. Yeah, it should be 61 by 1/19. This is something that you could pass to Cartopy or to declarative plotting or whatever else. You can also do some pretty neat operations like take the mean. And we get the mean value there. Since this is random data between 0 and 1, it's not surprising that it's about half. And notice, it's not just the mean, the coordinates are staying attached as well. Pretty cool. All right, let's do an air temperature selection. So remember now this has a totally different vertical coordinate. So I'm going to select time equal to 2021, 02, 01, let's say 1600. So now I have level, latitude, and longitude. So it's all levels for that given time at all locations. All right, so let's do one more fancy selection operation here. I'm going to go into air temperature. I'm going to select a latitude of 40, a longitude of 75, And then I'm going to constrain the level as well, but I'm going to use iCell and just say I want the 0th level, which is going to be 1000 HPA. So instead of constraining it by its value, I'm going to constrain it by its index. Now we get a key error because there is no longitude of 75. It should be minus. And now the only unconstrained thing is time. So what I've effectively extracted is the 24-hour temperature forecast for a given level at a given location. So now you could do something like make a plot of this. Import matplotlib.pyplot as PLT. Use our matplotlib inline magic. And I'm just going to grab this line of text. Plot.plot. And there is your 24-hour temperature forecast. You could, of course, find the maximum and minimum. By doing something very similar. What about if I removed this selection and just used the iSelect? Now we're getting the maximum temperature over any time, over any location at level 0. So as you can see, there are some really nice ways to slice into your data, get just what you want, and work with one all-encompassing data structure. I hope that you found these videos on XArray useful. I know I've certainly enjoyed getting to know the nuts and bolts of XArray a little bit more, and I'm sure that we're going to use it much more as MetPy is using it as pretty much the underlying data model for things. So I hope that you found this useful, and until next week, I hope that you found this useful, and I'll see you on next week's MetPy Monday.